a lot of people throw out ceramics as a buzzword for a good epoxy lining system without really giving any context to what is actually being achieved with that system. And in this video, we're going to go over in depth the different types of ceramics and where they're used and what you guys can use in your day-to-day and what you guys are doing to get the most out of your guys' equipment. So jumping into it, you know, the first thing that we always want to talk about is what is a ceramic. And for us, we most commonly just say, hey, this just means it's a high hardness, high wear resistant item. And so some of the key characteristics for a ceramic are, one, these are most commonly either an alumina, which would be an aluminum oxide, or some sort of silicate or a carbide, okay? And so for us common people, that just means this is going to be a high hardness material, which is excellent for abrasion. Now, real quick, before we really jump into the different types, when we're talking about abrasion, there are two ways we can solve this. One is to go the high hardness route, and the other is to go the low hardness route. And a lot of people say, well, which one's better? And the answer is both. It really just depends what you want to do. The high hardness route is the route that we most commonly take, which is using a ceramic or a carbide, something very, very high in hardness. Think like a diamond, right? A lot of people say, hey, you can't scratch a diamond just because of how hard it is. That's the approach we take. Now, some people will go the other route and pick something softer, with the idea being of, hey, rather than being very hard and scratch resistant, we just won't take the scratch, but we'll do it by catching that material and deflecting it, and then get our longevity out of the coating that way. So again, there's no really, this one's better than the other. It just depends on the application and what you're doing. I don't deal with the softer materials, and people that sell the softer materials don't deal with the harder materials. So it really just depends. So jumping into it, we have three main types of ceramic that I use in our coatings. The first one being a ceramic powder, the second being your beaded ceramic systems, and the third being your carbide grade systems, which can just be a variation of the first two, but there will be some different characteristics we'll get into as we progress. So jumping into the ceramic powder, it's something you guys can see here, and no, that's not the fun stuff for the weekends, but this is going to be much more flowery in nature, which is going to allow us to blend it into the coating much better. And so when we're going the ceramic powder route, one of the big things is, because it is finer, when we blend that into the coating, by looking at it, you're not going to be able to necessarily tell that's a ceramic coating unless somebody tells you it is. And some of the good benefits with dealing with a ceramic powder is, one, because it's finer in nature and we can blend it in smoother, we are going to get a smoother finish, which is going to enhance your fluid flow. A lot of people like it for being anti-fouling. So if any of you guys are dealing with like HVAC chillers or anything like that, where, hey, we have a lot of hard minerals in our water that we want to keep off the substrate, this is going to do great for that. And again, it's just going to give you that ultra smooth, that coffee cup like finish within your coating and reduce your surface tension, so that you can keep materials moving along. In a lot of cases with pumps, you can actually bump up your efficiency, and some people like that from a cost savings on the energy side, and others just like it from a, hey, if we're bumping up efficiency, what we're really doing is putting less of a load on the pump so we don't have to replace it. We don't care about the energy, because at the end of the day, we're going to spend that money anyways, but if we don't have to rebuild the pump, awesome. Now, where we most commonly use these or recommend people to implement them is in your brushable ceramic linings, and that's just because with the powders, again, we can go with a much smoother finish. And so with a lot of these systems, we need a thinner coating, something that's going to finish very visually appealing, because visually, if it looks smooth, mechanically we're also getting that smooth finish, which is going to have all the benefits I just mentioned. Now, moving over into the beaded ceramics. So with the beaded ceramics, you guys saw the powders. In essence, that's just the powders in a bead form. So where a lot of the powders are going to look like, say, big dinner plates if you zoomed in on a microscope. So those are designed to lay down so that as you brush your coating, then your ceramic is also laying down that way, which is going to enhance fluid flow. The beads are going to behave much, much differently. And because of that, you can see a couple different sizes there. with that beaded shape, they're great for deflection, because with the circle it's very hard to get a direct impact. So with these, instead of abrasion, we're going to switch more to impact, although they're great for abrasion, but that deflection is really going to take a lot of the energy out of the system that is trying to destroy it. And so with that deflection, these beads on the low end have a crush strength of about 18,000 psi. And so what that will allow your system to do is take a much greater beading, because you can pack more beads in the system. Generally, it's not going to be a brushable coating, it's going to be troweled on, allow you to pack more beads, which can take more energy. So you pair that crush strength with the fact that it's great for deflecting materials. What that will allow is, even though the crush strength is 18,000 psi, that's a direct hit. For indirect hits, that energy, I know pressure isn't an energy, but that force, that impact can actually be greater, because you're not taking a direct hit, it's coming at an angle. For those of us that took physics, you're some complicated math, but it's less than what that actually, if it's hitting at 30,000 psi or pounds of force this way, because the crush strength is this way, you can go above that 18,000 psi. And then the last thing is, with the beads, all the beads, not that the powder isn't, but because the beads can take up more space, and we're going to trowel those, right, so we can make it a more gritty coating. Those beads being 100% ceramic and being bigger and being able to pack more in the coating than, say, the powder in brushable form, we're actually just naturally going to get more wear resistance out of it. A lot of times when I'm talking with people, they'll say, hey, I have these ceramic tiles, I don't like dealing with them, I want to use your coating. How does it hold up next to a ceramic tile? And for ease of application, the coating is definitely going to be better, but in terms of wear resistance, 100% ceramic is always going to do better than anything less than 100%. And a lot of our brushable coatings, and what's most commonly on the market, is between 10, 15, 20%. So by rule, it's about 5 times better. But with the beads and being able to pack more in, we can get closer to that ceramic tile performance, but keep the ease of application with the coating. And so again, I already touched on it. Where do we most commonly use these? Typically when we're not worried about tight tolerances and we want something that we can put on thicker than your brushable coatings. Your brushables, you're typically 20, 30, 40 thousandths of an inch is what we recommend. With these, we can do 1/8 of an inch, 1/4 inch, a full inch. A lot of people don't go above that just for the cost associated with it, but that's something we can do. So moving into the last coating, and this is a carbide coating here. So this is going to be kind of a cross between the ceramic powder and the beaded system. So where the powder is very fine and the beads are obviously not very fine, right? They're much bigger. The carbide is going to be kind of in between. It's almost as if you shattered a bead but didn't quite pulverize it down to a powder. Now, one thing to note here with the carbides is a carbide is a ceramic, but a ceramic isn't necessarily a carbide. And from a all-out wear resistance perspective, the carbide is going to be the quote-unquote most wear resistant, just due to its higher hardness. It's got a little more robustness to it, so it's going to give you better performance. And one of the reasons I like it is, in talking about the ability for the beads to deflect materials, the carbides also have an imperfect shape, so you're never really going to get a direct impact on them. And while I say, hey, these are great, or they're classified as probably most wear resistance, I won't use them necessarily in a all-out abrasion situation, because they're not going to be smooth finishing the way a ceramic powder would be. But where we have some abrasion and some impact and we need even higher hardness, they're absolutely great. So where we most commonly use these is typically in like a medium build application, and again where we have a cross between abrasion and impact, and we can afford to step up into that carbide just because it is going to be a costlier solution, but it's very good when it applies. And if you guys look here in this picture, you'll see a 36 grit, an 80 grit, and a 120 mixed with a 220 grit. And even that 220 grit is still going to be very rough to the touch, with the 36 grit being more like a roofing shingle. If you guys can, you know, imagine what that feels like, or like a non-skid, if you've seen the tape they put on steps, that's more the finish we're gonna go with a carbide. So if we're looking for something that's gonna flow smooth, this wouldn't be it. But hey, we have a lot of tumbling going on in the system, and we don't necessarily need it smooth, but it's a mix of abrasion with impact, and it's real aggressive. The carbide's going to be great. So just recapping here before we get into the next section. So our three main types, again, are our ceramic powder, our beaded ceramics, and our carbides. Again, the powders are going to be much more like a flower, with the beaded ceramics being obviously a bead, and then the carbide being kind of a cross between the two, but a step up in wear resistance. Now, when we're going through, if a client calls and says, hey, I have an application, what would you recommend? These are typically my first three questions. There's a lot of offshoots to this, but these are kind of the three main categories. And the first one being tolerances. The second being, are we dealing predominantly with abrasion or impact? And lastly, what are our chemicals that are in the system, and what temperatures are we dealing with? So with the tolerances, we would have, you know, three options. No tolerances, think a big chute where we're not really going to affect anything. We have some tolerances, which could be something like in a pump housing, but not necessarily in the rotating, in your volutes or anything like that, where we have anything that we're going to affect fluid flow or the ability for the impeller to spin. And then we have our tight tolerances, where that could be where we have to worry about it spinning, or if it's on the impeller, where, hey, if we build up too much, we're going to put this thing out of balance. And so generally speaking, with the no tolerance zone, that could be really any of the three options. It could be a ceramic powder, it could be the beads, it could be the carbide, and that will lend itself more to the other topics. But as we get into tighter and tighter tolerances, that's where we fall into the ceramic powder zone, because we just have much more control over what that final finish is going to look like. Now, moving into the abrasion and impact, we covered a lot of that earlier, but really it just comes down to, what is the main problem? If it's all out abrasion, I tend to lean more towards the ceramic powders, because we can pack a lot of powder in there. We might go with a bead or a hybrid system, but those, generally speaking, when it's abrasion, it's most commonly sliding, or it's a fluid flow situation, air also being a fluid, so that's something that we want to protect against. If we switch to impact, generally I'm moving out of the ceramic powder into the beads or the carbide, and again, that just comes down to how aggressive is the application and what other limiting factors do we have on the system. Whether it might be, well, hey, we still have a little bit of abrasion in there, stick with the beads, or hey, we want the best thing we can do, budget's not an issue, and we'll step up into the carbide. And then lastly, this doesn't necessarily hit on what ceramic additive we're using, unless we're dealing with like a hydrofluoric acid with a lot of the silicate-based systems. That will attack the ceramics, so we do have to worry about that. But with the chemicals, with the temperature, what we really focus on here is what resins are we using, so that we can make sure, hey, we don't have an issue with what's going on in the system. So first one would be, you know, where are we on the pH scale? If we're real low, a real strong acid, then we might need to step up into a Novolac, and that's a whole separate conversation. If we're on the high side with like a caustic, we don't really have to worry about it. And then also with the temperature, the ceramics themselves can go up to like 1,000 degrees, but the resin, the binder holding it onto the substrate, that matters to make sure that, hey, the ceramic's holding up, but we're just tearing it off the substrate and sending it down the system. Now here's a little, you know, crude drawing tying it all together. So as you can see here, kind of tying it, right? So the ceramic powders can really cover all of them, especially, you know, up at the top when we're dealing with our tolerances. The beaded ceramics, not so much on the tolerance side, but great with the chemicals and temperature, great for abrasion or impact or both. And then the carbide, same thing, not really going to mess with the tolerances. Now you're probably wondering, hey, why do you have this kind of circle, this oval going through all of it? In some instances, we'll do hybrid systems. So if we have a lot of abrasion, a lot of impact, and tolerances don't matter, but what we've seen happen, let's say in this application, was, hey, we put this in and the beads held up great, but the resin didn't, and we were popping beads out of the system, right? What we'll do is we'll actually mix in ceramic powder with the beads so that the beads take up the big spots, and then the powder fills in all the small spots so that we can actually protect the resin from failing and then allow the beads to actually wear and get the full effect of the 100% ceramics. So in closing, and this is going to be a common theme with everything I talk about, there really is no best coating or best ceramic for the marketplace as a whole. A lot of people say, hey, this is the best thing I've ever seen, but then it might fail over here. And that's where we try to take a top-down approach and look at everything and say, okay, what's really going on with the system, and dial in what's best for that application. For a fluid flow application, although the carbide has the best wear resistance, the ceramic powder is probably better because we're on an impeller, we have spinning tolerances, we have mechanical tolerances that we need to worry about, and so it's better there. And then on the flip side, you know, the ceramic powder might be great for wear resistance, but we can't build it up real thick. So that's where we're going to switch over to a beaded system where we can put on more material to just give us more runtime. So again, there is no best. We're going to look at everything, ask a lot of questions, and go through that. So I hope this was helpful for you guys. If you have any questions, as always, drop a comment down below, and I'll get to you guys as soon as I can. Appreciate you. Godspeed.